Our next speaker is Dr. Casey Durande's physics student, Ms. Serena Sanchez. She will be presenting on man's best friend and enemies, defying the laws of physics.
So mosquitoes, dogs, bats, and pond skaters. What comes to mind for all of them? Anything? Disease? That's not wrong, honestly, but that's not the way I was going. But for me, mosquitoes, I think, are huge pests. Dogs, cutest things in the world. Bats, they creep me out. And before this, I didn't even know what a pond skater was, honestly. Strangely enough, they do have something in common, which is physics helps all of them survive. So today, I'll be informing you about 4 main topics in physics, including heat, sound, fluids, and forces, along with an animal in each category that either defies or utilizes the law. You know when you're trying to navigate through a dark room and you run into something, or you stub your toe, or you get out of the shower or pool and you forgot a towel? All lead into frustration. After my research, I thought these problems are actually pretty pathetic because all the animals that I'll be emphasizing would laugh at all these problems. So beginning with heat, living in Arizona, we have plenty of experiences with that, but we aren't the only ones who don't like it. Dogs are endotherms, so they can generate their own heat, but need to stay between 100 and 102 Fahrenheit. So if a dog has a soaked coat, it requires the dog to use an abundant amount of energy to stay warm. If all the energy is being used to stay warm, then there's a small amount left for other functions, so their body will react to the shortage of energy by speeding up its metabolism. In the end, the dog with a small amount of energy to do anything, that's not a life a dog is willing to live. So in order to avoid that, thermodynamics is actually avoided. Instead of allowing evaporation to use an enormous amount of energy, or convection and conduction to create a bubble of air between each individual hair to create insulation, trapping heat and creating small currents of convection, using thermodynamics would require more energy and it'd take a long time for the dog to dry, risking hypothermia in some situations or angering an owner with extremely wet floor. So instead, dogs will shake as shown in the picture. This is where simple harmonic motion comes into play. Dogs don't shake rapidly, but they follow this harmonic motion of going side to side, always passing through the center first. Their harmonic motion is also assisted by the dog's loose dermal tissue that creates a 90-degree turn every time for the dog. 60 degrees comes from the dermal tissue, and 30 degrees comes from the twisting of the backbone. This results in the dog shaking its fur after dipping in the water, so about 70% of the water actually comes off of the dog. In the end, resorting to oscillation instead of conduction or convention, dogs are able to survive without soaking wet coats and not go into hyperthermia or waste extreme amounts of energy. This leads into sound with the infamous bat. As defined in the book Furry Logic, sound is when an object is moving fast enough to set a medium in motion. In order to measure, frequency is used, which is the number of waves that pass a fixated place within a certain amount of time. The use of sound waves for bats is formerly known as echolocation. Driving in pitch black makes it difficult for any animal or human being to detect prey or obstacles. Using high-frequency pulses of ultrasound, depending on how fast ultrasound bounces back, tells how far an object is for a bat. The bat emits a sound wave from its nose or mouth, and when the sound wave hits something, an echo is produced. Upon returning to the bat's ears, it listens to signatures or variations in the echo to foretell how big the object is, how far it is, and even what shape it is. Bats are able to detect something as thin as a human hair using echolocation. To assist echolocation is the Doppler shift. A bat also utilizes Doppler shift to not deafen themselves when the high frequencies they emit come back. so the sound is shifted. So this means that it is a higher frequency which the bat can hear, but it's quieter when it returns. So it's able to utilize an aspect of sound to be successful in navigating at night and catching prey. Then there's fluid dynamics that describes the flow of liquids, which plays into walking across water. Seeing someone walking across water is something you read in books, but is done every day by an insect. An insect can sit upon the surface of the water only if its weight is less than the force of the liquid pushing it upwards. A researcher in the book Furry Logic found that the upward force depends on 3 aspects: liquid surface tension, object's length, and a maximum angle it dents the surface of the water below the horizontal. Unable to change the surface tension of the water, the pond skater can only affect its length and the maximum angle. Due to its 6 legs that are hinged at the middle, it boosts the total upwards force on the animal to a value well above its total weight. This answers how it stays above water, but how does it skate? Utilizing the 3rd law, which is if you put a force on a body, it will exert an equal and opposite force on you. It allows the pond skater to skate across the surface, creating hemispherical force vortexes and capillary waves. As the water is moving back, it pushes the pond skater forward. An example of the hemispherical vortexes is like one that you can create in a sink when you let it drain. So as long as adult pond skaters travel quicker than 25 centimeters per second, which is the lowest speed that a wave travels on a liquid surface, it will be able to acquire momentum to move forward. A combination of 2 different physics components, which are fluid dynamics and Newton's 3rd law, allow for pond skaters to acquire the name Jesus bug. Lastly are the forces that play in physics that help a mosquito live in the tropics. The mosquito survives downpours with raindrops as big as it. Raindrops fall from the sky at a speed of approximately 22 miles per hour. The heaviest weighs about 50 times more than the mosquito and are roughly always the same size as it. In order to survive, the mosquito utilizes Newton's 2nd law of motion and the concept of momentum. Newton's 2nd law is the rate of change of momentum in time, and momentum can be defined as mass in motion. Since mosquitoes weigh so little and a raindrop only has a force of 0.1 ounces, the momentum change is small. Although the raindrop hit increases the mosquito's acceleration greatly, the mosquito is able to recover in about 1.5 milliseconds. Additionally, they make the impact last as long as possible, which lowers the force of impact. The longer the force is absorbed. As long as the mosquito is in mid-air, it will survive. If a drop were to hit a mosquito while on a tree branch or too close to the ground, the insect will be hit with force that is the same amount as the momentum. That force is about 1.8 ounces, which is about 50,000 times the weight of a mosquito. So imagine me getting hit like a bus, that's what it is for a mosquito. Therefore, as long as the mosquito is able to absorb the raindrop's force and the mosquito remains at a low mass, flying in the tropic range will never be a problem, all thanks to Newton's 2nd law of motion and the concept of momentum. So overall, I hope that you take from this that try not to get too mad at your dog next time it shakes water off itself. Bats need to eat and find the way around, so echolocation helps with that. Walking on water is nothing for pond skaters, but definitely something for us. And mosquitoes really don't ever want to die. So physics is a complex subject that is based on a number of laws and concepts that have been research used before. Although the material may change, the concepts of heat, force, fluids, and sound remain as significant aspects of the world. The influence of physics on humans is widely studied, but how animals use it is heavily overlooked. Although not all animals utilize physics because some resist it, overall physics plays the same role in surviving for them in the world, whether it be dodging raindrops or skating over water. Without the physics, all these aspects would not be possible. Do we have any questions now? All right, thank you.